Another aspect of this is more to do with the verification side of inspecting gas membranes. How many tools do you guys use out there? What have you got in your toolbox? Now we see a lot of air lancing going on, a lot of dielectric testing, integrity testing as well. But if you refer back to 735 and the guidance, there is a lot of other testing regimes that we can use. So conveniently here today, we've got some of the more unusual ones. Some of them we'll use, some of them we won't use. But for example, we've got the needle and the air pressure testing. So when you've got a twin seam, we saw the welders in the other video, but this, and we're going to demonstrate these later on, how the needle and how you can air pressurize a channel to see how that works. Yeah. So I'm going to give reference as well to the ASTMs here, which is the American Standards of Testing and Measurement, because a lot of the standards are guided around that. We do have British standard codes as well. Again, I'll reference that in between the videos. Another piece of kit that's sometimes used, now this is used in conjunction with the vacuum bell or vacuum chamber test. Historically, it used to be a kind of two separate components, which was the glass chamber and then the pump. Now things have moved on a little bit, so we're just going to move over here. We've actually got a vacuum plate here, so this has actually got the motor and the pump built into it, so we don't have to use the two components here. So you can see the plate here, we've got a vision panel so we can see that. Again, we're going to run through some tests on that as we go through this morning. Got my water bottle there ready to squirt a bit of water on it so we can demonstrate that. Always have your tea towel ready to mop up and clean up, because we're going to be doing plenty of that. So I'm just going to flip over now, some more testing. A lot of you that have been on the training with me and we've done hand welding have done peels and shear testing, which is great for visuals. We can see what's going on and we can compare weld temperatures, etc. But if you want something a bit more regimented and some defined outcomes, the actual tensiometer here, we can see a version. We're going to run some tests with that later on today, just to see how that plays out and what kind of newtons, how much pressure are these welds holding. So I think this is going to be a useful bit of kit to have a look at. And I thought I'd just show you some supplementary items that I have knocking around in my bag, ready for any inspections and verifications. Some calipers. Confirming the thickness of membranes is quite important. Yes, the manufacturer will tell you a thickness, but are you going to take that for granted? Definitely worth having some calipers and just recording the thickness. Again, we'll hopefully see some examples of that. And one of the other ones that I've been using recently is temperature. I'm meeting a lot of technicians on site that claim to be welding at a certain temperature. I just use this kind of industrial grade thermometer just to check that we are seeing appropriate temperatures coming out of the welders, especially the handheld machines, which might be a bit dated. And as I said earlier, with the Leicester Triax, confirming that the elements are still in good working order. This is just a useful little test just to double up and make sure everything's good. So we're going to take a bit of time to look at some of the test seam methods that go on with the membrane. So we know that the twin seam welds are there and we've got the test channel. So just introducing some of the pressure testing kit, the needles. So here we have a very sharp needle to insert into this channel, and we've got the foot pump, the stirrup pump here to get the bar pressure. Remember, have a look at the ASTM for the required pressures and the time that you will do the test. So basically what we're going to do is pressurize the channel, hold it for a set period of time, and we are allowed a percentage drop in that time. So again, check the figures on this. I'm not going to quote anything now, and hopefully you'll be able to work out the correct pressure that's being held for the duration of the test. So I'm going to just pop this one in here now. I'm actually going to use a heat gun because inserting the needle into the membrane, when it's cold like it is at the moment, it's quite difficult to insert it. So I'm just going to pop this in and we'll take it from there. So we can see the needle being inserted here. The membrane was preheated using the heat gun just to make it more supple and to allow for the needle to insert. Plus I used a bit of extrusion rod there just to kind of ease the channel open, and you can see I'm using a clamp to shut the end off. So very critical as well. If we don't get the ends clamped off, we won't achieve the required pressure. So now with the stirrup pump, we're just going to insert, in this instance, we put 1 bar of pressure in there. So we were using the thickness of the membrane and the length of the seam just to look at that calculation. And you can just see there the needle's holding quite happily. So there's the channel inflated, you can see the obvious indication. The opposite end as well was trapped off. Some people use clamps, some people will use heat fusing it like we've done there. But there we can see is the needle is holding quite happily at 1 bar of pressure. Another little test that we just do, just to confirm, spray a bit of water, a bit of soapy water, see if there's any bubbling around that, which could indicate to any foul points. And there's the pump that we've used in this instance. So just returning to the far end here, we're going to release the pressure now. So just to see that there's a regular flow and we haven't got a pocket holding out. And again, the ASTM refers to how to discharge the air from the system. So we would do that at the opposite end from the needle.
Seeing the air channel test, I think if you are going to implement those tests, here we can see a section that's been welded up and we've come to a T interface. Now these are always going to be problematic because the welding we can see where I'm pointing at the moment is only to the top layer of the channel, so the bottom layer still exists. Be mindful, these could be potential pathways for our gases to migrate into the building and come through on the reverse side here. But little key areas, good practice here, we can see that the flap as well has been taken down. Often we see the capillaries in the flaps not being removed, but in this instance the technicians trimmed it away, so good practice there. So just wanted to do a comparison test with the air channel because we do see the twin seam welds being used on aluminium core products. And we all know the vulnerabilities of trying this test on this product because it can actually take a lot of the structure away from the membrane. So I've set the pump up and I've got the foot pump here ready to go. So I thought we just recap on some of the pressure seam testing, because we did try to do some reinforced foil product and it was very problematic trying to insert the needle because of the scrim. Wherever the needle encountered the scrim, it was kind of causing a hole. We couldn't get the pressure built up on that part of the test. So again, we couldn't build the pressure. But likewise, trying to pressurize these laminated aluminium core products is quite problematic because we know it takes a lot of the strength away. So if you're dealing with monolithic single products, then all well and good. But with the laminated products, beware. Just thought that would be a useful one to consider. If you are going to adopt it, check out the membrane first that you're going to be using that method on. So like everything, keeping everything in good working order. It's got its nice little carry case. And as you saw, I used a bit of water there, checking for any leaks. I was quite confident because the gauge was holding out at 1 bar of pressure. But using a bit of water just to confirm around the needle. We're actually going to look at some vacuum box testing now. So, but I just wanted to give this a clean up. Also carry a spare needle in case, because you can imagine these get pretty blunt. So be mindful you'll need to replace them. And keeping everything in its little home, always important.